do an x over x out. No x's are allowed out here. You can only put constants. Shit, how are we going to make that a 10x then? Yes?
Would it have been maybe like simpler to take out?
You could pull a 3 out, but you'd have to pull 3 from both of them. So it would become, a 3 comes out, so it would become an x, and that would become 2/3. Yes?
Would you have to like multiply the derivative by 3 and then maybe that by 10 over 10 to make it 30?
I see what you're saying, try and make them the same. There's a lot of different ways you could do this, a lot. What I'm going to do, it's not, you may not like it, but okay. I'm just going to multiply by 10/3 over 10/3. Because if I hit that with the 10/3, it's going to become 10x, right? This 3 and that 3 will kill off, and the 10 will become the coefficient, right? Let's just do that. And then do you have any problems multiplying 10/3 times 2? I mean, it's going to be a fraction, right? But we can do it, yes?
Yes.
Okay. So let me do it. This equals 1 over, right? Because that's going to go through, right? This one's going to go through. The bottom, we still have 10/3, 1 over 10/3, right? Yes, that will flip and become a 3/10 in a moment. I'm just going to leave it out here, though. On the top, 10x plus what? What's 10/3 times 2? 20/3. 20/3. And we are not getting our calculator and turning that into a decimal, right? We are comfortable with fractions in here. There we go. Okay. So far, I have the 10x, right? I don't have the minus 3. So I'm going to put here, next to this, minus 3 plus 3. I'm also going to go ahead and flip that fraction out front. 3 over 10. 10x. What did I say I wanted? Minus 3. So I'm going to put minus 3. And then I'm going to put plus 3. That's my hidden 0. That will make it match with this. But then I still have plus 20 over 3. (5x squared minus 3x plus 1) dx. Any questions? I've created what I wanted. Yes?
It's always going to be that number we want. No, I don't want to do it always, but it's...
Yeah. Once you get this to be whatever this coefficient, 10x, once you get that there, right? Once that's there, then whatever's here, you're just going to make it happen. So if this were plus 3, I would do plus 3 minus 3, right? If this was minus 7, I'd go minus 7 plus 7. In the previous problem, I think we had minus 8, didn't we? Something minus 8, and we needed minus 4.
Yeah.
And what was it? X? Was it X? What was it? 2x? What was it? 2x?
It was 8x minus.
It was 8x minus 4 is what we wanted, right?
Yeah.
But we had what up there?
8x minus 8.
We had 8x minus 8, right? Someone could have noticed here that you could have just rewritten this 8x minus 4 minus 4, right? You can rewrite 8x minus 8 as 8x minus 4, which is what we wound up doing anyway. But I went ahead and added and subtracted and added 4, right? Instead of breaking the 8 up into 2 pieces. The reason I did that is because when you get to something like this, it's not as easy to figure out how to break it up. So I always just insert it as a 0, if that makes sense. All right, we're happy now or not happy, but you see where we're going? These 2 terms over that is what I was hoping for, and these 2 together is a constant over an irreducible quadratic, which I can do with completing of the square. So I'm there now. I've made it to where I want to go. I still have a long way to go, but I'm at least somewhat happy. Okay, 10x minus 3 over 5x squared. I'm splitting into 2 integrals now. What are these 2 together? 29/3, right? Because that becomes 9/3. Add that. So this is 29/3. That's going to be on my next integral, right? So plus All right, out front, I have the 3/10. Do not forget this 3/10 has to pass through to both integrals. So I have a 3/10, and I'm pulling out of it a what? 29 over 3. So I'm going to write it down. I have 3/10, but I'm pulling out the 29 over 3. I'm not canceling it yet because I just want to make sure everyone understands that this is going to come out there with that, right? And then in here, 1 over, oh, should I pull that 5 now, or do you want me to go another step? I'm going to have to, sorry, right here. I'm going to have to complete the square, aren't I?
Yes.
I'll do it on the next step. Okay, yeah, this is going to suck. See, this one we're happy about, right? I mean, that's just a natural log. That's just a natural log. So that's going to be no problem. This one I have to complete the square. So I'm going to just continue over here. This is now 29 over 10 integral. Oh, wait, let's pull the 5 out of the bottom. 1/5 integral 1 over x squared minus, yes, this is your life, 3/5 x plus 1/5, right? Fractions, I mean, we're just going to have to deal with them, right? Pull a 5, pull a 5, pull a 5. That's what you have. Complete the square.
3/10.
Yeah, this is a weird one, right? So you have x squared minus 3/5 x plus a 5th. We're going to take the number in front of x right here and divide it by 2. So what happens when you divide that by 2? Yeah, minus 3/10. That's your first number, right? That's important.
Second number is 9 over 100.
Square it, 9 over 100 is your second number. That's the number you're going to add and subtract. Such is life. Add and subtract this. And then I still had here 1/5. These three terms are guaranteed to factor to be x, and then this number,
Plus 3.
right, minus 3/10, because it's negative, right?
All right, yes.
And then over here, we have to put those two together, don't we? So maybe get a common denominator. 11 over 100? Yeah. Yeah, you multiply top and bottom of this by 20, you get negative 9 over 100 plus 20 over 100. That's 11 over 100. Okay, hey, good news. It's going to be arctan again, because that's a plus. If it would have been a minus, we would go to either, what, formula minus, it would have been formula 20, right? All right, plus, let's keep going here. 29 over 50 integral of 1 over our completed square thing, x minus 3 over 10 squared plus 11 over 100 dx. I think we're good. I think we're there. That's the completed square on the bottom. This looks like 1 over u squared plus a squared. That's an easy one. So can we get our final answer now?
Yes.
Okay, the final answer is, where was it? This one right here we were happy with, right? 3/10 natural log of the 5x squared minus 3x plus 1. Right? All right, now, plus, right? Plus 29 over 50. Okay, the formula for this is 1 over a. A for us, ooh, we didn't talk about a. What's a? A is root 11 over 10, right? Because you have to take square root of top and bottom here. So a is root 11 over 10. So in our formula, it's 1 over a, right? So what's 1 over root 11 over 10? It's flipped, isn't it? So the reciprocal 10 over root 11? Inverse tangent of u, what's u for us here?
X minus
X minus 3/10 over a, which is root 11 over 10. Plus c, thank you. Plus c. I think there's some algebra we could do up front just to clean up. But do we want to? Not really, yeah. So let's see what Wolfram gives us on this. Like what? No, that's fine with me. Just like that's fine. Okay, so what was the original problem? What was the original problem?
Integral 3x plus 2
3x plus 2.
over 5x squared minus 3x plus 1
3x plus 1
dx.
dx. Do, 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 do. Oh, it wants pro. Why does it want pro? Wait, did I hit the wrong button or something? What happened? Hey, not bad. Not bad. Yeah? Now they use log. Log means natural log on Wolfram alpha, all right? And then I think we have this, don't we? That reduced to 29 over 5. And so they have the 29 on top, right? They have the 5 and the root 11 on the bottom. And then see how that's a little different than ours? All they did is they brought the 10. They flipped this, but they only brought the 10 up and did the 10 through there. That's the right answer. Good.
So I have a question.
Yes.
What happens if we have like a linear over something that is factorable?
Okay, so the question is, what do we do if we have a linear over something that is factorable, right?
The top linear doesn't cancel out.
And then nothing cancels, right? That's what the next class is about.
Oh, okay.
That, well, and we're going to start it a little bit right now because we're done with the examples. Okay? Let's start looking at the next topic. We should start now, okay? I know you want to go, but we still have time. Okay. So let's do one. Yeah, let's do one. You ready? So I want to recap. Constant over linear, we're good. It turns into natural log. Constant over repeated linear, we're good. It's not log, but powers, right? What was next? Constant over quadratic, that was missing x term. That goes with formula 17, 19, or 20, right? And then linear over irreducible quadratic. Oh no, constant over irreducible quadratic, complete the square. Linear over irreducible quadratic, yeah, sub it out, make it turn into what you want it to turn into, and yeah. Okay? So, how about something like this? What do we want to do here? So yeah, this is a constant over a quadratic, right? But this right here is reducible, right? That does factor. Now, if it didn't factor, what would you do? If it didn't factor, you complete the square, right? Now, you can still complete the square on this. You can. Because I put a constant up here, you can still use that same method, right? You can. Let's just do it real quick. If I completed the square on the bottom, what would you do? X squared minus 4x, you would take half of this number, negative 2, add it, square it. So you would add 4, subtract 4, right? And you'd still have the minus 12 there. These three would become x minus 2 squared, and then this will become minus 16. And do you see that you could rewrite that and use formula 20, I believe? Right? Does everyone see that? So for this first example, please everyone be aware, we could still complete the square and do this problem because I put a constant on top. In a little while, there will be something other than a constant on top, like a quadratic or something like that, okay? And that's more involved. So just to start though, I just want you to see with a constant how we could also do it not this way because it factors. So this turns into, if we factor the bottom, x minus 6x plus 2 dx. Now you have to know how to factor, all right? You do have to know how to factor a trinomial. Y'all agree that that's what it is? Now, here's where the whole idea of partial fractions comes from. Like, this is why we need it. If this were two separate integrals, right? If this turned into something like this, just imagine that this is what we had. Could you do those? Yeah, those are just natural logs, right? Because those are constant over linear. Those are the first ones we did today. Super fast, right? If we could split it into two. We can't split it into two, though, right? Unless there's a way to take this expression and break it down into a sum. That is what partial fraction decomposition is. That's why we learn it. It's so we can do this, all right? So we can break this down. So how does partial fraction decomposition work? We're going to spend all next class on it, but I just want to remind you, just start to get you thinking. Partial fraction decomposition, all right? If I'm looking at this, notice I'm not looking at the integral right now. I'm just looking at this expression. The idea here is, can I break this into some number on top of x minus 6 plus some number on top of x plus 2? The question is, can I do that, right?
Yes.
If I could, then wouldn't this integral be easier, right? The integral of this should be the integral of those two, and then life would be nice, right? Let's do it. Let's see, how can we do this? So what do we do? You remember?
You're going to try to get yourself the same denominator, so therefore a will be times x plus 2, and then x minus 6 will be times b. And all of that will be...
No, so we're trying to figure out what a and b are, right, that make this true? So what we want to do here is try and first clear the fractions. So we're going to multiply the left side and right side by the LCD, the least common denominator, which in this case is that right there. So we're going to multiply the left side by those two terms, and we're going to multiply the right side by those two terms. I am actually, right now, I am doing the procedure of partial fraction decomposition. I'm trying to solve for a and b. On the left side, I get 1 equals. On the right side, when you distribute this through, the x minus 6's cancel, and you get a times x plus 2. And then here you get b times x minus 6. Does this look familiar at all to you? No, it's brand new? Do you follow what I'm doing?
Yeah.
Okay.
On that.
So I would like to know if there's an a and a b that make this true, all right? So what I'm going to do next, when you get to this point right here, okay, there are two paths you can follow, right? When you get to this point, there's two different paths for partial fraction decomposition. There's a short method and there's a long method. The short method is great, but it doesn't always work. The long method is long, but it always works, all right? Is there a question? Yes.
Could you plug in 6 for x?
That's the short method. So I'm going to do the short method. We'll talk about the short and long in more depth next time. The short method, what I'm going to do is I'm going to try and figure out what a is first. And to figure out what a is, I'm going to see if there's a value of x that I can pick that would kill this term off. So I notice that if x is 6, this will go away. So I'm going to let x be 6. There's very few times in math where you get the freedom to choose something the way you want to choose it. This is one of them. I'm going to let x be 6 and rewrite this equation. See, by letting x be 6, this becomes a 0. And it kills that off. And over here you get x equals 8a. Right? Because 6 plus 2 is 8, and 8 times a is 8a. and divide both sides by 8, and don't you know what a is now? So I just figured out what a needs to be. Now let's do the same thing, and let's try and figure out what b is. So I want to know what b is. How can I do this same procedure here? Let x be -2, and that'll kill this off. So I'm going to now say, let x be -2. And that equation over there becomes 1 equals a times -2 plus 2 plus b times -2 minus 6. That goes away. You get 1 equals -8a. That's b. Sorry, that's a b, not an a. This is a b. So b is -1/8. And now you know what b is, right? So this original integral becomes, right, I wanted to split this up into 2 pieces. And what I figured out was that I can do it if a is 1/8. So this becomes 1/8 over the x minus 6. And then I have plus the b, which was -1/8 over the x plus 2 dx. Now they're separated, right? I have decomposed this into 2 pieces. And now I can bring things out and just do natural logs. We have a lot more to do with this, obviously, because this is just one case. We have a lot to look at. So in the notes, I actually go through and I remind you how partial fraction is done, or how to do partial fraction decomposition. So this is the strategy. I recommend you just read through this before class next time. You know, how we go through and try and do this. It shows you, it's going to be hard to read, but at least kind of look at it before class. We have all these different scenarios.
YouTube videos on partial fraction?
I probably do. It would probably be in my 1414 class or pre-cal. I have to look. The thing is, though, in those classes, they don't really go too heavy deep into it. I mean, like they do, but they keep everything, like the highest thing you get is like a system of equations with three equations, 3 unknowns, sometimes 4. We might actually get to 5, 6 unknowns here. If you have a calculator, TI, how many of you have a Texas Instruments graphing calculator? Almost everyone. Anyone not have one? Okay, what do you have? Do you have anything? Regular? What do you have?
Oh, wait, there.
Is it just a basic 4 function?
Yeah, I don't think.
Yeah, just a basic one. So the next part of what we're going to do next class, I'm going to be showing everybody on their calculator how to solve systems of equations using their calculators. And remember I told y'all that the tutoring lab will let you check out a calculator for the semester, a graphing calculator? Can y'all go look into that?
Takes 2 weeks, Professor.
Takes 2 weeks?
No, it doesn't. I got mine in a day.
If you have to like, you have to get approved, a QR code, but you
Uh-huh.
can get it for class. Like you can like give them your student ID right before class.
Okay,
Mine took like a day
really?
to rent it out for the.
Room 316, I believe, in Juniper Hall.
Yeah.
Room 316. If you go over there and say, hey, I would like to check out, because trust me, when we get to this, on a test, you do not want to get to a system of equations and have to do it by hand. So, and everyone does have access to it now, so. All right, we good? You don't necessarily have to have it next class, but I'm going to show the keystrokes on how to do it next class. What about?
Which ones do you want us to do?
Oh, homework. Good question. Homework for class over. Too late. Really, on partial fractions, there's nothing to do yet. We don't have enough. We don't have enough yet. We've set everything up. We're ready for it. So just do the quiz. Make sure you're watertight on the trig sub. You know. Okay. All right. Y'all have a good day. Good. Go turn off my camera real quick. Whoever's laptop or whatever's back here, you're welcome, sir. Just don't forget it.